So students that are weak in math will use these two terms, sequence and series, interchangeably with each other, but they are not. They are distinct. So I need you to understand the difference between the two, because we're going to build on that in Chapter 10. Chapter 10 is going to be all about series, not sequences anymore. So let's establish what a sequence is. Okay, a sequence written with brackets around a to the n is a listing of distinct terms. Oh. Undo. I don't know what I did there. I have no idea what I touched. Okay, a listing of distinct terms. So, like A1, comma, A2, comma. It's just a list all the way out to ... AN. When we discuss convergence of a sequence, it's the convergence or divergence of the last term. Okay, what is the last term approaching? That's what we were talking about in Chapter 9. A series. A series adds in the Greek summation, sigma symbol, applied to the sequence. A series is a list of progressive sums. And so it will start as A1, but the next value would be A1 plus A2. And the next value would be A1 plus A2 plus A3 plus ... till you get to the end. And then you've got A1 plus A2 plus A3 all the way out ... till you're adding the last term. Now, do these values necessarily always get bigger? No, because what could you be adding? Okay, so if the values of the sequence, not necessarily decreasing, but getting negative, okay, you can't just say decreasing, but if they have a negative difference, then the overall series or sum, that could be getting smaller. All right, so we are going to focus Chapter 10 primarily on what does a series do? Does the series converge or diverge? All right, so let's play with that a little bit. We're just going to experiment with a couple examples, and then I'm going to give you the rule that will apply. So we'll see if we kind of figure out the rule. All right, does the summation or the series applied to 3 over 10 to the n converge or diverge as and then on your summation symbol, as in starts at 1 and goes all the way to infinity. So does the series from 1 to infinity of the sequence 3 over 10 to the n, does that converge or diverge? So I just want to play with that, and then we'll come up with a hypothesis. So n compared to the distinct terms of a sub n compared to S sub n, which will be the progressive sum. So we want to compare the distinct terms to the progressive sum. So let's take n and let's kind of look at 1, 2, 3, 4, and 5, and then it will continue on. So our n values will start. We'll look at the first 5 of them and see if we can get a sense of what this is doing. So let's establish the distinct terms of the sequence. If I plug 1 into the sequence, what will I get? Okay, 3/10, which for our purposes right now, I'm going to write as 0.3. If I plug 2 into the sequence, what will I get? 0.03. And if I plug 3 in, 0.003 and 0.0003 and 0.0003. So those are the distinct terms of the sequence. Now the series. The first term of the series is the same because we're only adding one, only having one term added. The next term in the series will be the addition of the next term. And so what will I get? 0.33. And then the next time, I'm going to add the next one to it. So I'll have 0.33, and then 0.3333, and then 0.3333. Does it appear that the series, the values of the progressive sums, are they progressing toward any particular value? 0.3 repeating, which is progressing toward what number? 1/3. And so the answer is yes. By experimentation right now, it will converge to 1/3. Bad form, don't use it. S sub n will converge to 1/3. So we call that doing it by brute force, like literally writing out the terms and figuring it out. There is going to be a rule that you will be able to apply, but I want to do another one by brute force again, and just take a look at what the sequence terms are doing so we can figure out what the series terms are doing.
So, question.
Mm-hmm.
With a series, do you only ever use integers?
Yes. Yes, n is always an integer, starting with 1. Unless they specify, you might see that lower number, it might start with 0, or it might start with 5, or whatever. They'll tell you what to start with, but it's the assumption is that you're progressing through the integer number 6. All right, next one. Okay, does the summation, again, starting at 1 and going to infinity, of the sequence, -1 to the n, converge or diverge? All right, so let's do the same thing. Let's take a look at the first 5 terms or so of the sequence and the series. And I think looking at the first 5 or 6 maybe we'll look at 6, will be enough for us to get a sense of what this is doing. Okay, the sequence, the distinct terms. What is the first distinct term? -1. The second distinct term, +1. Third, +1, -1, +1. Kind of a sequence is that? Oscillating, okay, an oscillating sequence. All right, now let's do the sum. The first sum is also -1. And if I add the next term, what will I get?
0.
And then if I add the next term, what will I get? And if I add the next term, I will be back to 0, and then I will get -1, and then I will be back to 0. So that is also an oscillating sequence. It's oscillating between -1 and 0. So will this converge? Okay, no. S sub n will not converge because it oscillates between -1 and 0. So can we generalize these? What can we figure out that we've got in common? We got to look at the sequences themselves. Okay, in the first sequence, okay, so the sequence, the distinct terms, what's the common multiplier? Say that again? 1/10, okay, or 0.1. And so the common multiplier in this one, ooh, I don't like that. R equals 1/10. Okay, all right. And then in the second example, what is the common multiplier between the sequence of terms? -1. That's the key. It has to do with the value of the multiplier, whether or not the series is going to converge or diverge. All right, to summarize all that together, if the absolute value of the multiplier is less than 1, then S sub n will always converge. If the absolute value of R is greater than or equal to 1, then S sub n will not converge. And we can get even more specific. All right, a geometric sequence, which geometrics are always based on multiplication, who has R less than 1 will converge to the following sum. The first term divided by the difference between R and the multiplier. That little tidbit is a fantastic thing to know, that the summation, if the geometric sequence has a multiplying factor, that is, has an absolute value that keeps it between 1 and -1, then it will always converge to that sum. And so I'll show you how that would work in our previous example. So if we go up to our top example where R was less than, the absolute value of R was less than 1, and we check it, S sub n, which should equal 8 sub 1 over 1 minus R. A sub 1 in this case was 0.3 over 1 minus R in this case was 1/10. So that's 0.3, which is 3/10, divided by 9/10. Exactly, which is 3/9, which is 1/3, which is what we were hypothesizing that it was going to converge to anyway. All right, so let's just practice that. So far you're thinking chapter 10's not so bad. Okay. Are we going to do what? Multiply sequences together? Series together or sequences? Well, I mean, a sequence, you multiply a sequence, you just get a new sequence. So you mean, can you separate them?
Oh, I mean, multiply every single term together.
Oh, no. The series are only ever based on addition. All right, so will the summation starting at 0 this time, going to infinity, of 2 times 3/5 to the n converge? Well, just by looking at it, can you tell what the multiplier is? Say it again? Yeah. Okay, so the r is 3/5 as the multiplier, which is less than 1. So the answer is yes. Now, if so, find the value to which it will converge. So since it will converge, we'll need to know what our first term is. Okay, my first term is based on plugging in what integer? 0 actually is my first term. And when I plug in 0, I'll get 2 times 3/5 to the 0, which is 2. So the summation is going to have a value of 2 divided by 1 minus 3/5. So 2 over 2/5, which is 5. And so that basically means if you added up, if you found infinitely many distinct terms of the sequence and kept adding them all to each other, you'd be approaching the number 5 as a sum. You'll never be more than 5. Okay, will you ever get to 5? No. But you'll get close and you'll never exceed 5. Okay, let's try another one. All right, will the following series, pi over 2 plus pi squared over 4 plus pi cubed over 8 plus pi to the 4th over 16 plus, will that series, because it's a summation, they're not distinct, it's a sum, converge? All right, you said no pretty quickly. Why? What is the value of r? Pi over 2. Okay, pi over 2 is greater than 1. So no, S sub n will not converge. Okay, last one. All right, will the summation starting at 1 and going to infinity of cosine to the n of n pi minus pi fourths converge? Now, it is not obvious, at least not to me, what the multiplier is here. So for me, I need to do a couple of these terms so that I can get a sense of what the multiplier is. And so I need to, for my own, you know, work well, starting at 1, and let's kind of see what the multiplying pattern is. So if I plug in 1, what will I get? I will have the cosine of, I will have the cosine of 3/4 pi, which is correct, negative rad 2 over 2. All right, if I plug in 2, I will have the cosine squared of 7/4 pi, which is positive. Yeah, let's leave it like this so we're going to be able to see it better. And I'm going to put this to the first power. Okay, if I plug in 3, I will have cosine cubed of 11/4 pi, which is back to negative rad 2 over 2 cubed. If I plug in cos 4, and I'll get 15/4 pi, I'll be back to positive rad 2 over 2 to the 4th. What is the multiplier that's taking me from one term to the next? Negative rad 2 over 2. If I just keep multiplying by negative rad 2 over 2, so my r is negative rad 2 over 2. Is that greater than or less than 1? Okay, what about relative to negative 1? Because it has to, the absolute value of that needs to be less than 1. So in other words, it has to be between, is it between 1 and negative 1? Okay, negative rad 2 is 1.4-ish, so divide it by 2, you're at like 0.7, and so the answer is yes. Okay, the absolute value of that does fall within the range that we need. So, the sum of infinitely many terms will be the first term, which we determined to be negative rad 2 over 2, over 1 minus the r value, which we also determined to be negative rad 2 over 2. So we're looking at negative rad 2 over 2 over 1 plus rad 2 over 2. And if you clean that up a little bit, this is what you get. Multiply everything by 2. There you go. And that's the value that the sum will converge to.